So next concept is voltage. 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 Okay, next concept is voltage. So what do you mean by voltage? In one definition, in one sentence definition. Clear? It is the pulse. It is the pulse to moment the current. So current को जो moment कराए ताको हमें voltage कहया और it is called as a pressure or force. Clear? It is an electrical force or pressure which is required to moment the electric current or charge carrier in a conductor in a closed path. It is called as voltage. Clear? So its unit is V. So it denoted as what? V. Okay? And its unit is what? Unit is volt. Unit is volt. So let us consider in practically what is voltage. Clear? What is voltage? So let's take one example here. Two water tank is available at a different position. Clear? So here one tap is connected, one tap is connected. Tank 1 and tank 2. Clear? Tank 1 has the water level, higher water level, and tank 2 has the lower water level. If tap is open, due to the pressure of water, the water is flowing from upper to lower. This process is called as voltage. The moment of water is called as electrons. The moment of water is called as electrons. Clear? The pressure which is required to flow the water from higher level to lower level is called as voltage. Clear? So here this the next basic concept is resistance. So what do you mean by resistance, or what is the necessity of resistance in electricity? Okay, so we know resistance, it is the property of a resistor. Yes, it is the property of a resistor, or it is the property of any conductor, okay, which is opposes the flow of electric current. Clear? This is called as resistance. So this definition all of you know. Okay, so by using some practical example we can understand better what is resistance. Clear? So let us take one example with a water pipe. Okay, so this is the water pipe. So this is the water pipe. Clear? One cross sectional area is higher or large, then other one is less cross sectional area. Okay, so here cross sectional area is more, here cross sectional area is less or small. So this is the two type of what PVC pipe or water pipe we are taking here. Okay, then water is supplying, this is the water. Clear? So here in case of larger cross sectional area, the more water is flowing in this pipe. Yes or not? Yes. But same amount of water, if same amount of water is flowing in this smaller cross sectional area of PVC pipe, then less amount of water is existing here. That means what? So amount of water that is flowing from starting end to end, exit end is called as what? Current. Clear? So here the property of a pipe is what? The more quantity of water is flowing from one end to exit end. That means here let us analogy with this pipe into resistance. Okay, so here the cross sectional area is more, here cross sectional area is less. That means what? If the conductor have more cross sectional area, that means it has low resistance materials. That means what? If that conductor have the low resistance, then more current is flowing from the circuit. Clear? If the cross sectional area is less like this, then less amount of current is passing through these conductors, or less amount of water is passing in this pipe. Clear? Okay, use metric prefixes. So in resistance the unit is what? Ohm. Resistance unit is ohm. Okay, symbol is what? ohm. Clear? Symbol is ohm. So in case of resistance, it is denoted as R. Then the metric prefixes is what? Milliohm. Okay. Micro ohm. Okay. Kilo ohm. Mega ohm. Clear? So you have to remember this metric prefixes of resistance value. Clear? So that means what? This is milliohm. Milli means what? Milli means 10 to the power minus 3. Get it? Then micro means what? 10 to the power minus 6. Clear? Then kilo means 10 to the power 3. Then mega means 10 to the power 6. So this value you have to remember for all the times. Clear? So then the matrix prefixes for voltage. So B, voltage B, then millivolt, megavolt, yes or not? Kilovolt. These are the metric prefixes value of voltage. Then current I, milliampere, okay, microampere, then ampere. Clear? These are the current value using metric prefixes. So you have to remember all these values when we are calculating the numericals. When we are finding the value of current, voltage or resistance. Clear? Okay, thank you.